Lesson 6-2, Solving Two-Step Equations. So in this lesson, what you're going to learn how to do is solve an equation that involves more than one step. In order to get you warmed up for this, let's take a look at the solve and discuss it. Elizabeth wrote the following clues. What is the relationship between the shapes? So here you have circles, triangles, and squares, and you'll notice that in each of those equations, you have a combination of shapes on both sides of the equal sign. So your job is to figure out how the shapes are related, not to find a value for the shape, but just to see how they are connected to each other. So why don't you try that and come back and view the video to see if you have a similar relationship. So let's first take a look at the three number sentences. And what I did is I just summarized them by counting up the number of shapes that were alike in each of those equations and writing that as more of a coefficient instead of repeated addition. So in the first example here, in this first one, you have 4 circles plus a triangle. So there's your 4 circles and your triangle equals 2 squares and another triangle. And what you'll notice is that in this equation, both sides of the equal sign have a triangle. And what that means is that 4 circles must be the same as 2 squares in order for those to be equal. So 4 circles equals 2 squares. Okay? Well, if 4 circles equals 2 squares, then how many circles equal 1 square? Well, since all the circles have to represent the same thing, then what we end up with is 2 circles is going to be equal to 1 square. Oops. Now let's take a look at the second equation. The second equation has 3 triangles and 2 circles equal to 2 triangles and 1 square. In this equation, both sides of the equal sign have 2 circles. So what that tells us is that the 3 triangles must be equal to 1 square. Alright, so 3 triangles is the same, and those triangles are red. So let's do that over here. So we've got a red triangle, and there are 3 of them, and that's going to be equal to a green square. Now what I want you to notice before you move on is these 2 relationships here that we just got from those first 2 equations. If 2 circles equals a square and 3 triangles equals a square, then what must also be true is that 2 circles is equal to 3 triangles. And this relationship has to be a fact because of the relationship with the squares and each of those. So then when you look down here at the third equation, you'll notice that there are no similar shapes on both sides of the equal sign. So in this case, what you have to do is you have to use the previous relationships here and make that relationship with the third one. Okay? So we have 3 triangles is the same as 2 of the circles. So this could also be 3 triangles. And then we know that a square from this second relationship is also the same as 3 triangles. So what that means is 3 triangles and 3 triangles makes 6 triangles. So that statement is also a true statement there. Okay, so that helps us with looking for relationships between shapes, which will help you as you begin your solving two-step equations. All right, as we work through example 1, I want you to keep in mind that you can solve a lot of these real-world problems without setting up a two-step equation. You have strategies that you probably already use to figure out and solve problems that look like this, but we are going to be focusing on the process of how to solve a two-step equation and how to set that up in the solving process. So that's what I want you to focus most on today. Example 1 says Nala and 2 friends spent $21 on movie tickets and a box of popcorn. How could they figure out how much each movie ticket costs? So we know what their total amount spent is, and that's the $21 you see here in the bar diagram. And we know how much they spent on popcorn out of that $21. What we don't know are the cost of the 3 movie tickets. But we can get the cost of the 3 movie tickets by subtracting out the amount that the popcorn costs, $6, to find out that there was $15 left of that total amount spent that had to have been spent on the 3 tickets. And then we can further take that 15 and split it into 3 groups to find out that each of those movie tickets had to have been $5. Okay, so what we're going to be doing is working on something called isolating the variable. That means getting the variable part of your equation all by itself. So let's go back to the first bar diagram. We see the total amount spent plus 3 or equals 3 of the movie tickets plus the cost of popcorn. So here's your two-step equation that shows that. 21 equals 3 times the M for movie tickets plus 6. In the second box here, we have that two-step equation. And then I want you to remember what we did. We took away 6 from both sides of that equation in order to find out how much was spent just on the movie tickets. And then we took the movie tickets, there were 3 of them, and we divided both parts of that equation by 3 to find out that M is 5. So each movie ticket was $5. And what we did is we used what we call our properties of equality. In that very first step, we actually used the subtraction property of equality. The equation had addition, and in order to solve, we had to subtract on both sides to find out how much money was left for the tickets. Then in the second step here, we used the division property of equality because we knew that 3 times the cost of a ticket was $15, so we had to divide by 3 in order to find the cost of 1 ticket. So the properties of equality tell us what to do in order to isolate the variable and get it by itself. Now I want you to try it underneath example 1 and come back and check your answer. All right, go ahead and take a look at your try it question. Notice that I did fill in the bar diagram, but I also showed you what this looks like when you solve it as a two-step problem. Okay? So sometimes we don't have the context in order to be able to solve using other mental strategies. So you need to know what the 2 steps were that you do to solve that. Well, the first step is to subtract both parts of your equation by 4, because what you're doing is you're trying to take out the $4 that you know was spent on the bowling shoes. And what that means is that out of the $22 total spent, $18 remain for those 2 tickets, okay, or for the 2 games, for the bowling games. So then when you have already identified the $4 that was spent, now you've got 18 and you split it into 2 parts to find out that each game of bowling must have been $9. Over here you can see my equation solving process, and you can see how I've split my equation here, and I do that intentionally. I like to draw kind of like a T-chart type thing. And I subtract 4 from both sides. So that's this piece. Get rid of that. And that leaves you with the 2 B's equal to 18. And then you divide both sides by 2 to know that B equals 9. Example 2 works much the same way that I just did example 1. So you'll notice that they like to solve their equations in more of a horizontal format. I will show you here off to the side how I would set up the problem and solve it in a vertical format. You may do whatever you think is easiest for you. So let's first of all, let me move my page over a little bit. There we go. Okay, let me get my pen ready. And let's take a look at this equation. It says John has a $21.61 balance on a gift card that can be used to purchase online music. He bought some songs that each cost $1.29. So the songs were $1.29 each. And it says he bought D songs. Okay. And it says he now has $10 left. So here was the original cost of the gift card, the original amount on the gift card. And then he spent, so that's going to be subtraction, $1.29 per song. And he now has $10 left. Okay, so this is what the equation looks like. Because we are trying to figure out how many songs he purchased, we need to know how much he spent on songs. So in order to know how much he spent on songs, we're going to take away that balance from both sides. Bear with me here. Use your calculator. Okay, and notice that when you do that here, you end up with a negative 129D, because remember that was subtracted, so it's like having a negative there, equals, and here you get a negative $11.61. Now I know it seems weird that you have negatives in there, okay, but again, bear with me, because as you solve this, you are going to be dividing both sides by that negative 1/2900. And do you remember what happens when you have a negative divided by a negative? You get a positive. So $11.61 divided by $1.29 means that he bought 9 songs. Okay, what ends up happening is the negatives will cancel each other out to show that the answer is a positive value. Okay? All right, in example 3, what you are looking at there is how you can solve these both mental math and algebraically. So this is just another example, and it shows you how they set up an equation and show you the algebraic solution. So that's this piece right here. And then they also show you the arithmetic solution. In other words, how to just problem solve without writing the equation. Now what I want you to do is I want you to complete the try it underneath example 3 and then come back and check your answer. All right, first take a look at the equation here. 24 laps in a charity run, and then she walked 2/10 of a kilometer to the presentation table. She traveled a total of 29 6/10 kilometers. So we want to know the distance of each lap. That's the cursive L here. I didn't want to write a lowercase l because it looks like a number 1. So next, let's take a look at the solution. Since the equation has addition, we're going to be using subtraction in order to solve. By subtracting the 2/10 from each side of the equation, what we are finding out is what was the distance she traveled on the laps around the track. Okay, when the 2/10, remember, represents the distance that she walked to the presentation table. So once I take that out of her total distance, I know how much she traveled in total for all 24 laps. Next, because we have 24 laps, we need to know just the value of one lap. So we're going to divide both sides by 24. And what we find out is each lap was 1 and 225 thousandths kilometers. Again, get your calculator out and don't try to do all the math in your head. Check yourself on the calculator. Okay, as you begin your work here in lesson 6-2, I want you to remember from this key concept here that your properties of equality work the same in a two-step equation as they did when you solved one-step equations back in 6th grade. So your inverse relationships tell you how to undo the operations that you see in the equation. Remember, undo your addition or subtraction step first, and then you're going to undo your multiplication or division. And undoing them requires using that inverse operation. You'll notice that you have several questions here on the do you understand, do you know how, and your practice in problem solving. What I'm going to do is I'm going to make available my answer key, and that will be at my desk. You can come see me. I would like for you to try a couple of these problems on your own. You can try any of the problems in the do you understand, do you know how, or practice or problem solving on the next few pages. And then come see me at my desk or come check the front table and check your answers to those questions before you try the Math Excel. Okay, if you feel comfortable and you would like to try the Math Excels, you may go ahead and get to work. That is in your Pearson account.